last class we have talked about the concurrency transaction concept and the concurrency control. We didn't cover the details of every part of the concurrency control, but I believe that you get the idea of that. Sometimes it takes a month, more than a month, to complete such a transaction concept and the concurrency control in the database. But unfortunately, we do not have such enough time. Instead, we would like to briefly go over the concept of that. The last part of the advanced database design in this semester will be the database recovery technique. So I'd like to finish the database recovery technique as soon as possible. Then the remainder, I'd like to quickly review the second part of the semester. Okay. Any question before I start? So what is a database recovery? When system is crash. Actually, crashing is not it doesn't happen a lot, okay? But may happen. So then you want to recover. Right? So that is the recovery. But which means, how can you recover your crashed system? Backup. Without backup data, there's no way to restore. So, in other words, the backup is much more important than the restore. Actually, even though you do not know how to restore the system, if you have money, you can buy. You can buy the software, or you can hire someone who knows that. But without backup, it's very hard, almost impossible. Sometimes maybe possible, but it's very hard and it's costly. So, which means that even backup is not that simple in database. Why? How do you back up your operating system or file? You can just copy different media. So that's it. Then in case your operating system is damaged or sometimes the virus, then you can restore or you can go back to the previous image. Sometimes you can say that it's an image of your previous at certain time. So you can go back. What about the database? Database, can you do the same thing? Just copy the database system, then the copy again to the database? Sometimes yes, but mostly no, you cannot start your system. Why? What's the difference between operating system backup and recovery and database backup and recovery?
You could do system recovery and everything's lost, try to get back. But in database, I'm guessing because you do if you do system recovery at a certain time, you have to commit.
Yes, I think that he mentioned about the very important thing. When you back up your database system, you need to commit the data. Okay. In other words, database system is supporting multi-user system, concurrency control. In other words, it has a logical unit of the transaction. So what if we copy the data in the middle of a transaction? It will not be applied. However, for the other, so there are multiple transactions in a certain state at certain time. So if we can actually stop the time, then copy everything, then it will be possible. However, that's not the real story. So when you back up the data, when you copy the data, it will take a time. What if during that time the database is changed? You cannot apply such a change in your database state. So when you copy back the backup data, database system doesn't know whether this data is time t or time t plus 1, time t plus 2, because it took a time to copy the data. So unlike the operating system, database system, somebody said database system is kind of alive, okay, like. So I wonder, actually, long time ago, even the 500 years or 600 years ago, sometimes the people can, with the portrait, picture of yourself, right? The people, but it's very detailed, so it may take several days. I wonder how they can, without the camera, how can they draw such a detail. Probably they imagine they cannot stop the time, or the people cannot stand in front of the artist the several days. No, they cannot do that. But think about the database. Can we stop the database? Yes, you can stop the database, but during that time you cannot support any transaction, any service. So which is not mostly not allowed in the online transaction system. So that is a different thing. So you need to even consider such a thing. One of the way is you can shut down the database and copy the data, because there is no transaction when you shut down the database. But the problem is you cannot support any transaction. You can back up the data while the database is running. At that time, you have certain point, okay, checkpoint. Then I'm going to start the database backup at certain point time t. Then any change after that will be not committed. Okay, that time is the before and after image. So you can allow the changes, but the database backup will only copy the before image time t. Then any transaction that update the data will be logged. That is the after. But at that time, the system may be slow, but that may work. That is the real implementation of the backup. Once we have such a backup data, we can restore the system by copying such a data back to the crashed system. We can do that. So this is the overall database the database recovery technique. So in this chapter, we are going to see what is the concept of such a backup and recovery techniques. Okay. So I don't have to mention about the importance of such a database recovery. So there are different types of the failure. He mentioned about the system crash. That is one of the example of the failure. However, sometimes transaction can be failed. Okay, in the middle of the transaction, we have discussed about what is the transaction. Transaction is the logical unit, which means it consists of a lot of operation. It may be the failed or aborted in the middle of the transaction. That is also failed. So we should be able to recover such a transaction level and also system level. So sometimes hardware failure. So memory can be crashed, or sometimes the CPU is malfunction, and such a system failure. And the hard disk drive or such a media can be failed. The hard disk drive. So think about the mechanism of the hard disk drive. It has a header, disk COM. So there's a little tiny gap between the surface of your CD-ROM and the header. So if you throw the hit, so easily touch it, cause the scratch. The scratch is the most common failure of such a media. So at that time we may lose. Sometimes if you are lucky, it is the non-critical sector. But if the scratch sector is the system sector or some other header information, you may lose such a data. Okay? So from such a different, there's more types of. Sometimes entire the center may be the crashing. Okay, so that can be also the type of the failure. Anyway, so from such a failure, we should be able to recover such a database system. To do that, one thing we need to keep in our database system is the transaction log. Do you remember the log? What is a log in the transaction concept?
It's I take information.
So file which colors? It's a file.
file, transaction is a file. Yeah, it's a log is a file. Okay. So when do you log the such a transaction information? Whenever the transaction is started, you log such a transaction information. One of the example is the lock manager. So when we discuss about the two-phase locking, there are two main tables. One is a transaction table, another one is a lock table. So this is the same table for the transaction. This transaction log includes every action happened in the system. Okay. Then another example of the using the transaction log is when we commit the data, change the data. When we commit the transaction, what happens? The last step is logging. Log the transaction. At that time you can use such a transaction log. So your transaction will be end with not writing the change the data. That can be even after commit. Instead, we will see the example of that. But the transaction will be ended with the writing the action, any action of the such a transaction. Okay? So we are going to manage such a transaction log depending on the DBMS system. It can be the additional information. These are the basic operation like the begin, write, the read, or end, such as the transaction operation. And in case of the writing or the reading, we can keep the data item. And in case of the writing, the changing the data, we will keep before and after image. Sometimes some of the DBMS system manage the before and after image separately. So before and after image actually store that the memory. Okay, this is the. In case the memory is not enough, we can keep the such a before and after image the other. So this is the transaction log. Then there are different types of the update in the database system. So first, immediate update and deferred update. Immediate update means when you update a data, like for example here write the data from the 100 to 200, like the update the table, the employee table salary is equal to 200, where employee ID is 111, something like that. So when you update the data 100 to 200, at that time, if that new value is updated on the hard disk drive right away, okay? Then that is called the immediate update, okay? So this copy is updated. On the other hand, if the writing is deferred, postponed, it's updated in the memory only, okay? Not hard disk drive. That's called the deferred writing. Why? Immediate writing and deferred writing. Why do we need such a deferred writing? Yes? You raise your hand. Why? Yes, why? Writing the data on hard disk drive is slow. It's very expensive. It takes some time. So whenever we have updated data, if we write updated data on the hard disk drive, every time your system will be very, very slow. So we defer such a write. Forever? No, you cannot defer, postpone forever. When can you update the hard disk drive? When system is idle or not busy time. Okay? At the time you can write the data. Also, you can write which one is better. The every block by block writing or together. Definitely, if you can get together such an updated block and send it at one time, that will be faster. So that's the idea of the deferred writing. So mostly the current DBMS system use such a deferred writing. Think about the USB hard disk drive or the memory stick. Sometimes if you copy the big file and the operating system says it's done. So then if you plug out, what happens? You lose the file. Instead you need to check, safely remove the hard disk drive, right? Why? Because it's updated only in the memory. It's a deferred writing. So once you click that the safe remove the device, then they forcefully send the writing on hard disk drive. So at the time you may not lose the section information. Another type of the updated data in database is a schedule update and in place update. In place update is you can directly update a block, okay, where the data is originally located. On the other hand, the schedule update is think about the multiple copies, okay? So like the mirroring. So you have exactly the copy of the database. Then once the data is updated, you are not going to, there might be primary and secondary, but you are not going to update the primary right away. Instead, the secondary. Why? For better performance. If you write the data every time, probably it's a bottleneck or the slow. So you can update the data and schedule from time to time. You need to synchronize such a data. So depending on the whether deferred or the immediate update, deferred update, and so there might be the shared schedule update and in place the update. Okay. As we have seen the last class, so database also has sometimes it's called the cache manager or sometimes buffer manager. I mentioned several times the importance of the buffer. Database, one of the main reasons of using database management system is what? Accessing the data very fast. However, if you compare the file system to manage the data versus database system itself, database system is not faster than the file system. File system itself is a low level of the processing. So sometimes it will be faster. You can just open the data and read the byte. Yeah, that's it. However, database system, you need to log one, connect, and select the data. You need to process the SQL and the query optimize. It takes a longer time. But mostly, using database system is faster. How? We learn index, right? That's one thing. And also we can find the fastest way, so query optimization. Another one is, the third one is such a cache, using cache. Okay, so database require actually the huge amount of cache. So instead of accessing the hard disk drive itself, so we can get the same data from the memory. That's the idea of the cache, any types of cache, like the memory. Okay, how many percentile of the data can be read from memory comparing to the hard disk drive? How many? If you read the 100 block, how many of them can be read from the memory? It's a 97%. So if you have, that's called the hit ratio. Hit ratio means the number of blocks from the number of I/O from memory versus the over total number of I/O. So 97% from memory, only 2 or 3% from hard disk drive. What about when you start your database system? Startup. Is there any data on the memory? No. So anyway, you need to read the data from hard disk drive first. Then eventually it will be increased. But 97% is too high, right? How can you get the data, 97% data from the memory out of 100? only 2 or 3 blocks read the data, the hard disk run out of 100. How can you keep such a high the heat ratio? Why? Anyway, you need a bigger size of memory to keep such a data. Another one is not all the data can be used throughout the day, throughout the daytime, or throughout the week. No, only few of the data. Why don't you consider your laptop? How many files do you access in terms of a percentile every day? Only 1 or 2% of your data you access every day, right? Even less than 1%. Why don't you think about the bunch of files? How many pages? Only few. Actually, my daughter, the bag is too heavy. I always ask how many of them actually you are using the school daytime. Only few, but she tries to keep all of them. Yeah, that's natural, that's usual. So it's the same thing. Database guy, they don't want to throw away. Nobody wants to throw away their data. Only few of the, it's called the 20 to 80 rule. Only 20% of the data are used for the system on average, in general. 80% is for what? Nothing? It's not nothing. It's for historic data, or just in case. If there's a very mean customer in your banking system, they try to see all the transactions last 10 years, 20 years. Anyway, you need to serve. It's a very rare case. So only few part of the data are accessed. So why don't we keep such a data on the memory that is called the buffer management? Also, when we had the changes of data, as we have seen the last class, it's not directly write the hard disk drive. Instead, we try to manage what? Before image, after image. Image means before, and after image means it's a buffer. It's a cache data. So who is in charge of the managing the cache? It's a cache manager, or sometimes called buffer manager. There are specific algorithms. Probably you heard about the LRU algorithm, least recently used algorithm in your algorithm, right? It's the LRU algorithm. Even you will learn the LRU algorithm in the operating system for what? Whatever, I forgot. So that such an algorithm, the LRU algorithm, you should know if you are taking operating system class. It's really the final reason. But not in the database, it's too much detail, but they have their own algorithm to manage the buffer, list of the buffer. Idea is, if that one is used recently, you can keep in the first. So then, from time to time, they can modify data, will be flushed, applied to the hard disk drive. That's the main job of the database cache. Okay. So such a cache manager manage each buffer using the modified and the pin unpin the bit. So each block had not each block. For each block, the buffer manager, the cache manager, has the one bit to represent the pin or unpin. That means if you pin the specific block, that will not be flushed. It's a pin on your blackboard or the bulletin board. So you cannot take out, you cannot flush it out. Unpin means the operating system or your system. The buffer manager can apply such a change into the hard disk drive. The modify or dirty bit means that if that is changed, it's after image. We have discussed about the before image, and AFIM is after image, after image. So after image, so before image, after image. For example, if the transaction is not completed, not committed, other transaction need to access before image. Okay. However, I'm the transaction that update the data, so there uses the after image. Even though that is before commit, okay, it's not commit yet, but I need to access the after image. How do you do you need to access the first data buffer? No, you don't have to. Instead, the cache manager check the bit, manage the 1 bit for each block, okay, buffer, then whether this is the before image or after image. That is the modified TB. Okay. Okay, so database, the backup and recovery basically based on the 2 operations. So one is undo, another one is redo. Do you remember the redo and undo? What is the redo? Do it again. Why?
To make it sure.
To make sure. So you execute the operation. Okay. So if the database system use the immediate writing. Okay, immediate writing means when you update the data that is applied to the hard disk drive. Hard disk drive is permanent. On the other hand, if you are using the default writing, it's the update data is in the memory until flushed out. But memory is volatile. You will lose the data if you do not have the power. So such a default writing sometimes causes the problem. I update the data and commit it, but it's still in the memory. But system crashes. We need to get the changed data, but it's still on the memory. But we have what? Log data, transaction log. Transaction log is always in the hard disk drive. So using that transaction log, check whether such a change is applied to the hard disk drive or not. You may check, right? When you restore, during the restoration, recover step, you can check. If not applied, you can redo one more time. Okay, that is a redo operation. On the other hand, undo is opposite, right? For example, I update the data. I'm updating the data. Huge amount of the data, like the 10 millions of the data. It takes 2 days. I cannot commit yet. It's just one query. Okay. So during the updating, you have for each block before image, after image, before image, after image. Where? Memory. So until commit. But it's a huge updating. Your memory size is limited. So you cannot give all the before and after image in the memory. Then stop your update. That may be one solution, but your customer user may not be happy if you stop in the middle. Instead, you can update the hard disk drive. Even though it's not commit, to update the hard disk drive. Then system crashes. It's an old image or a new image on the hard disk drive. It's updated data, but it's supposed to be previous one. Should go back, right? So how do you know that? Check the transaction log, whether it's committed or not. If not committed, you need to go back, previous one. How do you know the previous data? How do you know? Here you have the before image. So you can keep the before image. How can we go back? That is the undo operation. So these two, redo and undo. Why do we have such a redo and undo operation? Because of the default writing. Okay, if we write the immediately, so we don't have to worry about it. But because of that, and also because of the transaction. Okay, that is the redo. So redo is a roll forward. We again roll forward, and undo means it's a roll back, go back. Okay. So for example, Oracle database we can keep the such a before and after image in the log, transaction log, but transaction log will be easily grow if you have a lot of update. Also, if you have the millions of transactions at the same time, that transaction needs to access same time. Even though read the data, then the access should be able to access the raw data. It will be kind of bottleneck. So Oracle database actually separate before image and after image in the separate file. That is called rollback segment. So rollback segment keep the before and after image. Where is it? It's on the hard disk drive. Okay? So that is a rollback segment. So, but it can be in the transaction log, either it can be the separate file. But both of them should be the file system, hard disk drive, not in the memory. Okay. So that is the rollback and the roll forward, undo and redo. So basically the recover, backup and recovery, the operation is based on the such a undo operation, combination of the undo and redo operation. If you understand this one, so actually the backup and recovery is quite easy. However, if you concept itself is easy, but the real story is not. So for example, if your system sometimes can be shut down without any reason, you cannot find the reason, just like your laptop. So sometimes late or sometimes hanged or sometimes shut down. So it may happen in the server, database server also. Then you may lose data, so you need to recover the database system. However, there are many different the scenario. Okay, each and every case is different. So transaction is committed in the client side, but not in the server side, or sometimes it's a network failure. So the system is alive, but the network is not okay. So there are a bunch of different stories. So even the vendor, there are many companies who support such a backup and recovery, but they cannot understand such a business flow. Okay, so it is recommended to make the kind of scenario of the failure and recovery the manual. Okay, like the fire drill. Did you do the fire drill in your elementary school? So middle school, I don't think the university are doing the fire drill, but from time to time, you will hear the noisy sound, then you need to go out. So it's a kind of fire. You need to do the same thing for the database system when you manage the database. Okay, but they are basically based on the undo and redo operation. If you understand this one, so in case something problem when you restore the database, you can easily understand. So we are managing such including transaction log. So our transaction should be ended with the writing all the action in the log data. That is called the write ahead log. So write ahead log is the in place update. It should be in place, not memory update. Why? Because that log is our final one. Okay, to restore data. So if that is logged in the memory, we may lose. There's a chance to lose the data. So such a logging operation should be done in place. Okay, that is for the write ahead log. Using that write ahead log, if you fail, so your transaction is almost complete. So you try to log such a commit information, but it's not. You write, for example, COMMI, but you cannot log the T, so it's not committed on your hard disk drive. At that time, if your system is failed, it will be go back undo. It's not committed data. So your commit, your apply, your synchronization should be done with such a logging in the implies the hard disk drive. That is the most important part in the recovery, backup step, backup and recovery step. So that is the undo and redo. So undo and redo operation will read such a log information. When, however, from time to time we need to write the data, change the data from memory to hard disk drive. So there are several the condition when we are going to write the data from hard disk, the memory to the hard disk drive. One of them is the checkpoint. So checkpoint, you can firstly send a command checkpoint, which means the address checkpoint, okay, commit the current status, all the changed information will be applied to the hard disk drive over at a certain time period. So like the within 5 seconds. If there is no checkpoint, there is no change, falsely you can write the data. Or there are several options like this here. To understand the database recovery, so there are different types of the backup and the database recovery step that can be classified as the steal, no steal, okay, and the force, no force. Steal means, what does it mean, steal? Right? Even before commit, you can apply the data from memory to hard disk drive. It's kind of stealing. It's not committed, but it's applied to the hard disk. That is a steal. So if your system allows the steal, that means the cache information, the changed information, changed data on the memory can be flushed into hard disk drive before coming. Even. That's what I mentioned here. The long running transaction, you cannot keep hold the data, okay, in the memory. So you need to apply. Even though before commit, you can apply it. However, no steal means until commit, the change data in the memory will not be applied. What if there are long running transaction, update the data, so your entire memory is used. The no steal, no way. You need to stop and terminate such a transaction. However, in case of steal, even before commit, it can be flushed into a hard disk drive. So steal is general case in most of the database system. The first means the cache data is immediately applied to the hard disk drive. Okay, that means it's an immediate write. Okay, and no force means it's until commit. Cache is a deferred. Okay? So we can consider the different combination: the steal, no steal, and versus the force, no force, which means that we can have the steal and no force, and steal and force. For example, steal and no force. No force means the steal means it can be applied to the hard disk drive even before commit. So that may cause the problem of the non-commit but change it. So we need to undo. So that is the reason it's called undo. Redo means it may change because it's no force. No force means it's a default write. So sometimes it's not commit but not applied to the hard disk drive. So we need to redo. Similarly, steal, force means the steal causes undo, and the force means it's right. You don't have to redo. Okay? And the no steal, no force is no undo, redo, and the no steal force is no undo, no read. There are 4 different types of the database recovery system. So when you develop or when you select the database, you need to, depending on your requirement of your entire system or the business policy, you need to select. Nowadays, most of the commercial DBMS use steal, no force. Okay? And that means the undo and redo are used. Okay? So you can, even for me, I got confused. This one. So remember, the most of the commercial DBMS system, including the Oracle, SQL Server, MySQL, they are using the undo and redo operation, which means steal, no force. Steal means it can be applied without commit, applied to the hard disk drive, and the no force means it's the default write. So this is an example of the. I'm going to skip the other 3 parts, only steal, no force. So steal. So this is the, in general case, general system, the undo and redo algorithm, but there are different environment. That means if your system supports a single user, it's much simpler, but the most of the case, is a concurrent execution, multi-user system. So multi-user system. So the undo and redo algorithm will be used. I like to ask the question. So I give the certain case like the update. I'm using still no force the system. What undo and redo. So I update the data so that is committed but only in the memory. Then he unplugged your database server. That's crash, right? Then what happened when you start up the database system? So in other words, so this is what? Computer. Then we have operating system, and this is the EBMS. So we access the database system using SQL Plus and submit the update. Employee information salary 122. Okay? So update. What happened? So read the data from 1, bring to the memory. This is 1. It's a multi-version concurrency control. So 1, 2, 2. And also it's a committed. Then this system support undo and redo operation. Or still or no force. Then this time it's a committed. But not flushed yet. And he unplugged the power. You lose memory information. Then when you start up the database again, explain what's going on. Nothing?
No.
This is supposed to be 2, but it's still 1, right? What happened? Nothing?
Well, it didn't commit, so because it didn't commit, they lost.
No, you may not, because it's a support, undo and redo operation.
So something.
Yeah, you need to explain something. Using redo and undo algorithm. You should have what? Log data, right? Hash log, transaction log. Okay? First, the system will read the data from log data. Okay? So if this log has a begin transaction of this one, transaction, for example, transaction 1, and update this and commit and end. Clearly show this one. Then check the employee information whether this is 1 or 2. This is 1, but supposed to be 2. Then you need to do redo operation. Okay? Then you can run, execute this command again and commit. That is recovery start. Then this one will be 2, then system will start up successfully. This is called instance recovery. Instance recovery actually happen many of the system. Sometimes you may not realize. Operating system also uses such an instance recovery. While system is started, check the log data and the memory data, hard disk drive data, whether they are synchronized. If not, they will redo or undo such an operation. This is the redo operation. What about undo? So for example, update the data 1 to 2, not commit yet, but this one, 1, 2, 2 before image, after image, then this one is changing before, because there is no more space on the memory. Because this is still no force system. Then crash it, okay? The unplug, crash it, and start up. What happened? Check log information. There's no commit, but this one's supposed to be 1, but it's a 2. You need to do undo operation. how can you do the undo? Update? No. You can just apply before image. That is logged in your log file. Right? So this is undo. Any database recovery operation is basically a combination of this. But problem is it takes a long time, usually. In this case, it's simple, but in real recovery step, sometimes you log the 1 day's data, so you need to undo and redo 1 day's operation. It will take several days. It's longer than the real transaction time. Because they need to check one by one, everything for each log data, check. So, yes.
I kind of lost
Hmm?
when you said when you before you connect for the redo you do one and then
Redo or undo?
both.
Both.
So you confuse me with
It's
both.
the same idea actually. So let me explain the redo again. Okay? Redo means, so I update the data committed. So data, all the image is 1, 2. So you commit. It's supposed to be applied here, hard disk drive, but it's still no force. You don't have to forcefully write the data. It's a default writing. So it's still 1. Later you can update it, but before before writing back to the hard disk drive, your system is crashing. So it's 1 or 2 when you start up. It's 1, but it's supposed to be 2. How do you change the data? Using redo operation. But you should know what should be redone. How do you know that? Log data. Log information. Okay? That's it? That's the redo. That is the undo and redo algorithm. You don't have to worry about too much the other undo and undo redo for operating system and other system use such a concept also. But database system, most of the database system is undo and redo algorithm nowadays. Okay. Shadow paging shadow paging means we have another set of the same data. So instead of updating this one, then another one, backup. For what? For better performance. However, you need to synchronize. In case somebody would like to access this data, should be synchronized. Such an idea is nowadays used. It's called a materialized view. View. What is a view?
The view is a virtual table.
Virtual table that implement idea of external view of 3 schema architecture. You don't have to have the many table for the student. Instead, you have 1 table, but it can be viewed differently. That's the view. It's a virtual table, which means physically it's a 1 data, but virtually it's a many data, right? So it doesn't have the real data. However, materialized view means what is this? No. It's a New York. This is LA. It's the United States. So we have the employee table here. So LA system actually has the view of New York employee view. So using this view, what happened? You need to actually travel through the network. It takes time. There is a network latency. Okay? Right? It's not real time. It takes some time. So to address that problem sometimes, so we can have the real copy of the employee. Because the employee is not frequently changing, right? Even though the new employee, nothing do. So every night we can update the data, synchronize the data. This is called materialized. Physically locate the 2 things, okay? But one is a shadow. It's not from the user point of view, you cannot see it, but it's physically located. The main problem, how often you are going to synchronize the data. And it's the same thing. When you access the data, when you are going to synchronize. So that is the shadow paging. And sometimes such as shadow paging can be done in hardware level, not the database level. Yes. This is the example of the recovery algorithm, but I don't think you can pay attention. You need to pay attention. You don't have to. Okay? Then, which means it's done. Okay. Any question? Which means you are ready.
No.
Okay, so after the midterm, the final exam, first of all, thanks so much throughout the semester. I'm going to back to the previous schedule, which means that this semester, as I announced at the beginning of the semester, I'd like to cover and more topic in the advanced database design. So, which means I little bit shrink the first database design part. It was very tough to even though explain everything and finish everything. But I believe that you guys have been doing very well and a very good job. So, but I do better. Go back to the original.